Today we're going to start to look at how we multiply polynomials. We worked with addition and subtraction of polynomials last week, which was similar to just combining our like terms. When we're multiplying, we're thinking of that distributive property, and it's going to be similar to that. So take out your notes packets to this page and follow along. So when we're going to start by just multiplying a monomial by a polynomial. So remember, monomial is one term, so that 2x to the third is my monomial, and then what's in the parentheses is my binomial because it has 4 terms. What I'm going to do is I'm really just using my distributive property here. I'm distributing my 2x to the third, multiplying it by x to the third. So again, this is where our exponent rules from last unit are going to come in, because now we're multiplying x to the third by x to the third. So I add my exponents and get 2x to the sixth. I'm just going to keep distributing my 2x to the third. So I get plus 6x to the fifth minus 4x to the fourth plus 10x to the third. And we can see too that we can't combine any like terms here. It's in the proper form because our exponents are going from greatest to least already. So I'm done here. Let's do the next one together. So here, again, applying or distributing my x. So I get 7x to the third plus 4x. Take a minute, pause the video, and then when you're ready, come back to see the answer to number 2. We're now going to look at multiplying polynomials using a table. So we're multiplying 2 binomials here because we have 2 polynomials that both have 2 terms. So I'm going to put my 2x plus 3 on the top, and then I'm going to put my 4x plus 1 going across the side. So again, each term in that binomial has its own box. And this is just going to help us now to do that multiplication. So now in order to get what's in the box, I'm going to multiply those 2 terms that make up that box. So for example, 2x and 4x. Well, that's going to give me 8x squared. 3 and 4x gives me 12x. 2x and 1 gives me 2x. And then 3 and 1 gives me 3 for this box. So now I just multiplied those 2 binomials together, and I know I have 8x squared plus 12x plus 2x plus 3. And I can combine my 12x and my 2x because those are like terms. They both have an x. So my final answer in simplest form would be 8x squared plus 14x plus 3. So that's one way we can multiply binomials. However, making that table is not always going to be the fastest method. So what we're going to use a lot is what we're going to called foiling, or the FOIL pattern, which is basically just using the distributive property. FOIL stands for first, outer, inner, and last. So what that means is, if you look here in red, I'm multiplying my 2 first terms, and then in green, I'm multiplying those outer terms, which are 2x and 1. Then I multiply the inner terms, which are 3 and 4x, and then the last terms, which are 3 and 1. So you don't necessarily need to remember what that pattern is. We just call it FOIL. I would suggest using the arrows like they have here to make sure we're always getting multiplying each term where it needs to be multiplied. So here I'm going to take my a, I'm going to multiply it by 2. I get my 2a squared. A also gets multiplied by 1, so plus a. And now I moved over to my second term. So I'm going to multiply 3 by 2a. So again, I get plus 6a. And then my last would be 3 and 1. So this is plus 3. I can combine all of these now, or combine my terms, which is a and 6a. So my final answer is 2a squared plus 7a plus 3. Take a minute, pause the video. When you're ready, come back and check your answer for number 2. I recommend using those loops. I think it's really helpful, and it's a strategy to make sure that you know you're multiplying each term it needs to be multiplied in the binomial. And then don't forget those integer operations and that you are combining your terms at the end. Let's go to the next page now. So this is where that distributive, thinking of it as that the distributive property is really helpful as we get into multiplying trinomials by binomials, because again, we're multiplying each term in that first polynomial by each term in that second polynomial. So again, using those loops, I'm going to take b squared and multiply it by 3b. So this becomes 3b to the third. I take b squared and I multiply it by -4. So I get minus 4b squared. Let's move over to the second term now. That second term needs to be multiplied by everything in that binomial. So 6b now needs to be multiplied by 3b. And I get 18b squared. And 6b needs to be multiplied by -4, which gives me -24b. And then lastly, I need to do the same with that 7. So that -7 gets multiplied by 3b, so I get minus 21b. And then I get plus 28. So now we need to make sure that we combine all our terms that we can, and make sure it's in proper order from the largest exponent to the smallest exponent. So my final answer here would be 3b to the third, because I can't combine that. I can combine the -4b squared with the 18b squared to get positive 14b squared. -24b minus 21b gives me -45b, and then that plus 28. And I could see it's also in the proper standard form, because 3 is my biggest exponent, and it goes down in order. Pause the video, try the next one on your own, and come back when you're ready to check. There's your answer to this one here. The only difference here is that the binomial is first, but same concept. We're taking everything in that first polynomial and multiplying it to every term in that second polynomial. Try these ones on your own now. Come back. I'll post the answer key in a second. And here are the answers to those 4 problems.